Hello everyone, I'm Yoonji from UIST. Today, I will introduce SchemaBoard, a visual computing tool for makers helping to assembly and inspect a circuit. This work is collaborated with Hyein, Ramkrishna, Prasad, Seungwoo, Youngkyung, Choi, Daniel Ashbrook, and Ian Oakley, and is advised by Andrea Bianchi. Many makers struggle with reading schematic circuit diagrams. They can use the pictorial circuit diagram. Still, there are hitches as the physical circuit gradually diverged from the pictorial reference. To inspect the mismatched circuit with reference, makers should understand the topologies of the pictorial circuit, and it's difficult. To address this issue, we propose SchemaBoard. SchemaBoard is an LED Bentley solderless breadboard that can programmatically illuminate its rows to reflect the components or nets that are interactively selected in a schematic shown in a companion software application on a tablet PC. Both et al. Pointed out the difficulties of building circuits. There are systems to aid users, but they focus on learning and do not work with schematic diagrams. There are also augmented breadboards to help makers, but they do not support for the situations in which circuits are still under construction. To better understand the issues during circuit breadboarding and inform the potential solutions, we conducted comparison study between pictorial circuit diagram and traditional schematic diagram. We could infer the reason for the higher workload of the pictorial circuit from the results of comparing reference and physical circuit. There were inconsistency between pictorial reference and actual circuit on breadboard. In the qualitative results, users reported that schematic is difficult to interpret and translate for breadboard circuit. Pictorial circuit is easy to use, but it gradually diverged from pictorial reference due to the accidental mistranslation or intentional improvement. As a result, users needed to convert pictorial circuit into schematic and map it onto the breadboard again for reviewing. However, participants said schematic circuit benefits them in problem solving due to its logical and abstract representation. The formative study results suggest a need for tools that can combine the advantageous qualities of both abstract and pictorial representation of circuits. Based on the formative study, we developed a system which highlights the location of hardware components. This is the SchemaBoard hardware. It's an Arduino shield that consists of LEDs and shift resistors. Users can import custom-designed schematic circuit files to SchemaBoard system. SchemaBoard highlights the location of the breadboard for the selected component. To indicate the component's polarity, SchemaBoard blinks the LED. Also, SchemaBoard blinks the LED for the first pin for the chip. SchemaBoard also uses highlighting to show all the rows connected to selected electrical nets, giving an overview of connectivity even on crowded breadboards. In guide mode, SchemaBoard guides users to place hardware components first and then depict the location for wires. Guide mode provides step-by-step circuit assembly for all the elements of a circuit, so users can easily complete the circuit without mistakes or bugs. We conducted an evaluation study with 16 makers to compare the task of assembly and inspection of circuits using either SchemaBoard or a baseline involving traditional use of schematic diagrams. In the quantitative results, completion rates were significantly higher in the inspection task for the SchemaBoard group. Also, SchemaBoard led to significantly faster performance with less errors than baseline. The success rate of SchemaBoard group were higher than baseline group in both assembly and inspection. SchemaBoard group appreciated for the easy and intuitive interface of SchemaBoard. Also, all participants reported that SchemaBoard supported them though they have different levels of expertise. In this presentation, we proposed a system SchemaBoard. From the formative study results, we derived a need for tools that can combine the advantageous qualities of both abstract and pictorial representation of circuits. Based on that, we designed and developed SchemaBoard system. The results of the evaluation study showed that SchemaBoard led to faster prototyping, fewer errors, less workload, and more confidence in circuit implementation. Thank you.